So we're going to have two different problems. This is our first one today, a toy rocket and a drone. And you're going to need to pay attention to detail on this. You're going to use specific values and units. And what you need to do is look at these graphs, and I need you to like make a paragraph of words where someone that doesn't see these graphs could graph exactly what's happening, or almost exactly what's happening, okay? Like paint the picture with using specifics. We're not going to compute anything. We're going to use language to say what's happening and when so that we understand what each graph is saying. So 1 and 2 are going to go together. So number 1, you're going to like write a little paragraph saying this is what's happening. This is how I know. On 2, you're then going to go label things on the graph, like show why and where you're seeing those things. So you're going to do this with your partner. Probably take a solid 5 minutes, maybe up to 8. Let's go. I have a lot of room to write on here, so let's get I'm going to shorten some of this up, but here are some of the key factors you would need. For the rocket, I'm going to do them separately and then like erase it. So for the rocket, this is actually number 1. I'd say something like you're going to need to have that it starts at 25 meters. Climbs to a, I'm going to use a fun word here, maximum of 40, I am doing question 1. 45 meters before falling back. Oh, wait. I'm going to give more. I'm going to give more details. 45 meters, how long does it take to get to there, though? At 2 seconds?
25
and falls back to Earth.
What if they're on Mars?
At 5 seconds. Then it blows up, but the graph just stops at back to Earth. We don't have the blow up portion. So you would need these things. Here's some things that we have. We have a starting point or y-intercept. All right, so this is kind of number 2 now. Starting point or y-intercept, also called the vertical intercept. We've got a maximum right here. Okay, let's call him Max. Okay. And then we've got a horizontal intercept or an x-axis there. And we have 2 factors every time. We have time and a height. All right? So this would be like a y-intercept, an x-intercept. So these are some defining characteristics of that graph for the rocket, correct? But let's talk about this drone, man. The rocket, I like thinking about the rocket too because it brings back some memories of me. We'd go out, we'd take it with us ice fishing on the lake and let some rockets go, chase them down. Okay, so for the drone, where does the drone start?
On the ground.
Starts on the ground, right? And that'd be right here. This is where it starts. The y-intercept and x-intercept, or the starting part. And then I would say goes up 10 meters per second for 2 seconds to a max of 20 meters. And then it chills there, technical term, until 5 seconds.
Pretty lucky that their rocket just flew so straight.
Then it comes down 10 meters per second.
Yeah, I'm just
And then I ran out of room. Up here, we're going to go up here.
like in real life.
Until it hits ground at 7 seconds. So defining characteristics here, my max would be this whole interval, right?
Yeah, that's true, Mr.
That's the max, right? Here, this interval here, I said 10 meters per second. I've got a starting point, I've got an ending point. This is an x-intercept here too. And then I gave this interval the negative 10 meters per second. So I have a lot of defining characteristics that I can explain exactly what happens. So you can see this. The rocket's on a ledge, gets shot off a little bit, comes down to Earth. Same speed up and down, so no parachute or something. Okay? And then this drone goes zzz, up, chills at a spot, zzz, comes down. You can like visualize exactly what's happening. All right? Yeah, it makes that sound. Zzz. Or maybe that was a weed whacker. I don't know.
I think that's a bee.
Let's set up what's going on here, what you're going to do. So there's bungee jumping, right? Everybody knows what bungee jumping is?
Yeah.
Okay. And so here's everything you're going to need. There's going to be 2 slides. You're going to have both things on here. This is all the information you need. These are different aspects of the graph right here. and these would be called expressions or equations. Then these are all defining characteristics of the graph. They match these. The defining characteristics match these things, okay? And then you should be able to see them on the graph. What your job with your partner is to fill out this table. So the table is going to, let's do the first one together. The table is going to give you the greatest height that the jumper is from the river. So then you're going to go back here and you're going to look at, well, which expression or equation shows the greatest height? So it looks like the greatest height is 80. Everybody good with that? The greatest height is 80?
Yeah.
So I'm going to go with this one right here. This says at what time is it 80? Right? That's what this says. At what time is it 80? So h of t is 80. That's what's going to go on my table. H of t is 80. Once I write on here, I can't go back though. And that says, that's the expression, or that's actually an equation, where it shows that height. What's the feature on the graph for where it's the highest? We call that the maximum. That's one of those bullet points. So you're going to use your expression equations and your bullet points of features to fill out this table corresponding to the events that happen bungee jumping, all right? You're going to do that with your partner. I'm actually going to leave this page so that you can be on this slide on your paper. And then you can just look at this for all the information you need.
That's smart.
Okay?
No.
Then you don't have to flip back and forth.
That's facts.
All right, let's get after it. Let's fill out that table. The one we already looked at, the first one, we said this is the maximum, right? And we said the time that it's 80 would be the maximum. That's your first row we did together. This is going to be a little tricky because I got to flip back and forth. And I can't like keep writing on it as I flip back and forth, but we got this. So the height from which the jumper was jumping, which expression would show that?
H of t equals 80.
H of t equals 80.
You did that with
We did that one up here.
Oh,
H of 0.
H0.
sorry, I thought you were.
Which means where is the jumper after 0 time, right? And what's the feature of the graph for h of 0, Sean?
Vertical intercept.
The vertical intercept. We also call that the y-intercept, right? Okay. So there's the second row. I just want to go back, previous slide, to show you when there is 0 time. Oops. When there's 0 time, here we are, right here, right? At 80. At 0 time. So that is our maximum, like we said earlier, but that's also our y-intercept. This one, for our purposes, would be the vertical intercept, our starting point. All right, let's look at the next row.
H of t equals.
We've got the time at which the jumper reached the highest point. I need an expression for that one. All right, Josiah, which one you got for that one? For C, the time it reached the highest point.
HT equals 8.
80. So this is saying, at what time do they get to the 80, right?
What?
Yeah, it's 45.
Oh, 45. Not the highest point after the jump.
I was about to say.
Okay.
I don't think I got
So
that
this
wrong.
is after it bounced back up once. This is looking nice. I'm going to make that even look nicer, 45. Okay, and what's the feature of the graph for this? Elsa? Just say that again?
First peak of the growth.
First peak, right? So that's a defining feature of the graph. Let's go look at it.
How do the next one?
I think so. So, here we've got, it's saying, here's the first peak of the graph, which is at h of 4. At 4 seconds, we reached the second. You know, you bounced back up. You kind of come back up towards where you started. We all good?
Yeah.
All right. Let's go. We got one more to do. All right. Yeah, help me out, Troy.
It's H of 4.
The lowest point is at 4 seconds, is what you're saying? H of
Yes.
4. Okay, what's the feature of the graph that you would call that?
The first dip. Yeah.
First dip.
I think I got the last one.
Okay. And let's go look at that. The first dip. So we got h of 4, which means 4 seconds after is right here. That's the lowest point. It makes sense, right? You're sending it all the way down. This is going to be the first dip. We can also call this, if we wanted to, the minimum. It's the lowest it goes. Now let's talk about this one. Everybody's thinking it. At what time is he at 0? Well, guys, this would be a not very good bungee jump business if they allowed him
Just touch the
Chilling.
to get to 0.
It's the horizontal.
Because that means his
And he will
head.
die. Still within.
Yeah, so it's a good thing that this doesn't work out in this graph. That would be our horizontal intercept, correct? But as you see our x-axis,
Yeah.
good news for our bungee jumper,
He did hit the ground.
he didn't hit the ground this time. Not
We
yet,
kinda
at least.
lit.
Not
He
yet.
put, like,
Here, spoiler alert, here's the rest of the graph.
Oh, he did.
Psych, no, they let him down to the ground gently, okay? Or it was a river. Okay, it was a river. Let him down, got to swim.
Crocodile.
All
Or
right.
he drowned
Happy,
with all that equipment
only
on.
happy ending, all right?
I don't know.
I'd be so scared.
Now, what you guys get for the h of 0?
Whee!
How much time? That means at 0 minutes, where was it? H is 0.
8.
Where was he at 0 time?
80.
Oh,
80. And after 4 seconds?
he was at 10.
10. So there's our maximum and minimum, right? Okay, and then what time was he at 45?
He was at 45. Where did we about 9 seconds?
8,
8.5.
8 to 9 seconds somewhere. I think I wrote 9 on mine, but yeah, in between the two. And then this says, what time was he at 0?
No.
Never, right? There is no answer to that one. Thank
That'd be kind of
goodness.
sketchy, yo.
That would be a little sketchy.
Rio.
Even Flat Stanley would say so. Okay. So you guys are going to go do this cool down. It is going to be what you need to finish before I give you your homework. Here it is about squirrels, man. I bet you weren't seeing that coming.
I actually saw a squirrel out